Okay, so this is these are the solutions to the derivatives handout. So the first couple are pretty straightforward. I mean, the first one's almost trivial, but we'll go through it. So f of x equals 2/7 x to the 5th power. So we use two rules here. We use the constant multiplier rule and we use the power rule. So what we're doing is we're taking the derivative of the function f of x with respect to x. So, and you don't, I'm just writing this out to demonstrate what's going on here. So, and then we'll just tell you what you really need to know to be able to how to do. So the constant multiplier rule says that if you have a constant times a function, you can take that constant outside the derivative, and it's just that same constant multiplied by the derivative of the function. So we're saying the derivative with respect to x of x to the 5th. So this is x to the n. So the derivative of x to the n is n times x to the n minus 1. And then you just simplify the two constants that are multiplied together. So you get 10/7 x to the 4th. Now you can go straight here if you wanted to. 5 times 2 is 10. Divide by 7, reduce the exponent by 1. The second one is where you have to rewrite a function in the form where you can use the power rule. So if you have something at the denominator raised to a power, you can move that to the numerator. So let me write the function down first. -4 divided by x to the 4th. So the first thing you do is you write that as -4 times x to the minus 4. So now, same deal. We've got the constant multiplier. So if we want to find f prime of x, so I'm using two different notations here. Here was ddx of f of x, which is the same as f prime of x. So I'm just going straight to f prime of x. So what you'll have is -4, the original constant. Then you use the power rule. So you take the exponent, -4, and then you write the last term with the exponent reduced more negative. A lot of times people will go the wrong direction here. They'll take 4 minus 1, which is 3. But here it's -4 minus 1, which is -5. Okay, so you do two things. You clean up the constants. So in this case, -4 times -4 is positive 16. And you move this to the denominator, so it becomes positive. So that's f prime of x. Okay, the next is an example of where you can not use the quotient rule, but take the original function and just simplify it into separate terms. So sometimes in calculus it's better to kind of unsimplify things. So we may have simplified this, found a common denominator or something like that, but the reality is to take the derivative, it's better to divide each one of these by x squared. So you'll get x squared plus 2 minus 3 over x squared. And before we take the derivative of each term, we're going to rewrite the last term where the positive exponent in the denominator becomes a negative exponent in the numerator. Exactly what we did over here. So now we can take the derivative of each term separately because we're just adding or subtracting terms. So we can use whatever the appropriate law is. So here we're using the power rule. Here we're using the derivative of a constant, which is 0. And here we'll have -3 times -2, which is positive 6. Reduce the exponent by 1, make it more negative. Subtract 1. And then finally, to get it in the final forms, we can drop this term, the 0 term, and we'll move the negative exponent to the denominator, make it positive. So that's the answer. Now you could use the quotient rule, but if you once you simplify everything, you would end up with something like that, or the same, an equivalent expression. Okay, the next one is just to do a multiple part polynomial, just to show you that just because you have a lot of terms doesn't really make it that hard, because you're taking the derivative of each part separately and then just adding the results together. So f prime of x, so we take 5 times 2, which is 10, reduce the exponent by 1, 3 times 3, which is 9, reduce the exponent by 1, 4 times 2, which is 8, reduce the exponent by 1. Now we don't need to show x to the first power. Just remember, anytime you take the derivative of x squared, you get 2x. And just leave the exponent off. The derivative of x is 1, so you just get negative 12. And the derivative of a constant is 0. Okay, so the next one is where we actually have to use the product. Well, we don't have to. We could multiply it out using FOIL, and then, but we're just using this as a way to demonstrate the mechanics of the product rule. This may not be the most efficient way to do it, but so if you have a product of two terms, what you do is you can call one of them f of x and the other one g of x. That's why I called it h of x. If you were given something that was called f of x, you could just rename it h of x if you wanted to. Let's say I call this f of x. Well, I could just say it's h of x, and that just makes it easier to stay with this same naming convention. I know how to come up with the word. Okay, so we take the derivatives here. They're just polynomials, so 2 times 2 is 4, so we get 4x. Derivative of x is 1, so we get that here. 2 times 3 is 6, 6x. And derivative of 2x is 2. Okay, so we just plug it in the product rule. And the product rule says, let's just write this out, the derivative with respect to x of a product of two functions, f of x times g of x. And this is just a combination function, multiplying two functions together. It's not a composite function, it's just a multiplication of two functions. So what we said was that that is going to be equal to f of x times g prime of x plus g of x times f prime of x. So one you take the derivative, the other one you leave the same, then you flip it around. So now we can just plug in what we have, which would be 2x squared minus 5x for f of x, g prime of x. It's going to be 6x plus 2. G of x is 3x squared plus 2x, and f prime of x is going to be 4x minus 5. Now usually when you get to this point, you do want to simplify. So we're going to use FOIL. So go ahead and multiply this out. I'll go ahead and do it now. Okay, so 2 times 6 is 12. X squared times x is x cubed. Okay, so that's first. F FOIL outer. So 2x times 2 is 4x squared. 2x squared times 2. Then we get negative 30x squared from here to here. And then you get negative 10x for the 1. So you get a cubed term, two squared terms, and a single x term. I'm going to do this one right below it, and we can kind of add them together vertically. So you're going to get 3x squared times 4x, which is going to be 12x cubed. We'll get 3x squared times negative 5, which would be negative 15x squared. I should have really combined these two, but we'll do that in a second. Okay, so you get negative 15x squared plus 8x squared 2x times 4x, and then you get 2x times negative 5, so it's negative 10. Okay, before we add them together, let's just go ahead and combine the x squared terms. So you got negative 26x squared minus 10x, and then the second line, so let me put a plus here to make sure I'm consistent. Okay, plus 12x cubed. Combine these two, you get negative 7. Add these two together, you get well, we're not going to add them together yet. We're just combining these terms here, and then we can add vertically. So we get 24x to the x cubed, 26. That's going to be negative 33x squared, and negative 20x. So that's the answer. Now, I'm just going to go ahead and multiply it out before we take the derivative, just to make sure I did that right. So we'll get 6 times 3, that's going to be 6x to the 4th here, and then we'll get 2 times 2 is 4, so it's plus 4x cubed minus 15x cubed and minus 10x squared. So now if we take the derivative of that, we'll get 24x cubed. 4 times 6 is 24. These two together will give you negative 11. I should have simplified that before. Let me do that. Okay, let's combine these two terms before we take the derivative. So I have 6x to the 4th minus 11x cubed minus 10x squared. Okay, now we can take the derivative. So you get negative 33x squared minus 20x, and hopefully that's what we just got. 24x cubed minus 30. Yep. Okay, now for the tough one. So this one's got an extra term in it. So it's just giving you some practice at polynomial multiplication. So we're going to say h of x is equal to x cubed minus 2x plus 1 times x squared plus 4x. Okay, so we'll call the first term f of x, and the second term g of x. And then we'll take the derivatives. So we got 3x squared minus 2, and g prime of x equals 2x plus 4. So h prime of x is going to be equal to, so we'll take f of x times g prime of x. Plus the other way around, g of x times f prime of x, like that. And we're going to multiply this out. So when you do, you don't really do FOIL because you've got 3 elements, but you basically take this times that, this times that. Then you take the middle term, multiplied by those 2 terms, and then the last term. So x cubed times each one of those will give us 2x to the 4th plus 4x cubed. So we get this times that is that, this times that is that. Then we have negative 2x times those 2 terms, so it would be negative 4x squared minus 8x, and then 1 times each one of those. So 1 times 2x is 2x, 1 times 4 is 4. Okay, then we'll do the same thing here. So x squared times 3x squared is going to be 6x to the 4th. We're going to get 2x cubed terms. 4 times 3 is 12, so that's plus 12x cubed. And then we'll get negative 2x. Well, actually, we just get cubed from here, and we'll get squared from there. So we get negative 2x squared. And then the last will give us negative 8x. Okay, before we add these things together, let's see if there's any terms we can combine, which we can. So we'll have negative 8x plus 2. That'd be negative 6x. I'm just going to double check I did this right. Okay, that looks right. Okay, and here we can combine actually none of them, so I'm just going to put a plus sign there. Plus 6x plus 12x cubed minus 2x squared minus 8x. Okay, now we'll add them. So we'll get 8x to the fourth plus 16x cubed minus 6x squared minus 14x plus 4. And again, I'm going to just do this to make sure I did it right by multiplying this thing out at first. So h of x so we're going to get x to the fifth plus 4x to the fourth minus 2x cubed minus 8x squared plus x squared plus 4x. Make sure I get this right again. This times that and that. Okay, got two terms to add together. Okay, so that's h of x. And if we take the derivative of that, we'll get 5x to the fourth plus 16x cubed minus 6x squared minus 14x plus 4. Drum roll. What did I do wrong here? So it's that first term. What did I do? What did I do? Oh, yeah, you probably already figured this out. So when I did that, I get 3x to the fourth. So add this together, you get 5. Now we're match up. Okay. And the last one is pretty straightforward. It's one that we're not going to be able to do a whole lot of simplification with. So we have a polynomial term and a trig function term. So we're going to let f of x equal x cubed plus 2x squared. We'll let g of x equal the cosine of x. F prime of x is 3x squared plus 6x, and no, 4x. 4x, 3x squared plus 4x. Okay. G prime of x. The derivative of the cosine is negative the sine. So the product rule says you take that times that. And that times that. I want to put the polynomial first. Now, I put these in parentheses because if you don't put the parenthesis, if we left this parenthesis off, it wouldn't be obvious that we're multiplying it. We might think we're subtracting it if I didn't have this here. So that definitely needs to be involved. Now, typically, you have the sign first. So the sign here is negative. So I'm going to put that out front. Then I'm going to put the parentheses around this term so that I know that the minus sign applies to both terms. And then I'll put the trig function last. And I don't need to put a parenthesis because it's a plus now. So there's no confusion. I don't put a plus in here. I just leave it off, and that's obviously a plus. So, and there's the second part, which I'll do in a second. But we wouldn't want to do this. This would be bad. Something like that. Because what I would think is it would be negative x cubed plus 2x squared times the sine of x, which has a completely different meaning. This negative applies to both these terms. And the sign is multiplying both of those terms. So the parentheses serve a critical part of that expression. And the second one, we really don't have to do anything. We just leave as it is. We typically have the sign, then any polynomials, and then any trig or not transcendental functions like inverse trig functions, logarithms, exponentials. Now, if this were multiplied by the sine of x, then we might combine them, but because one's multiplied by the sine and one's multiplied by the cosine, we pretty much leave it. Okay. So the next one is just an example of using the quotient rule, plus a few other little things. So, we can't divide. There's two terms in the denominator, so it's not like we could do earlier and simplify this. So this is pretty much the form you're going to get. And we'll let the numerator be called f of x. And we'll let the denominator be called g of x. Now you have to rewrite the cube root as a fractional exponent. So the square root's 1/2, the cube root's 1/3, the fourth root is 1/4. We don't have to do anything with this one. So now we can take the derivative using the power rule. So you're going to get 1/3 times x to the minus 2/3. 1/3 minus 1 is negative 2/3. And g prime of x is just 2x plus 0. We don't need to show that. So we just apply the quotient rule, which says that the derivative with respect to x of a quotient of two functions is equal to, now I always forget which is first and which is second. So because I've been doing it forever and I still can't remember which order it is, I'm going to look it up in the book, and you can just look it up in the book, or you can write it down on some piece of paper known as cheat sheet. Okay, so where am I here? Product rule, quotient rule, there we go. So it's g of x times f prime of x. There's probably some way I can remember this, but I guess because I know I can look it up, I don't worry about it too much. I always know it's divided by, that part I knew. So it's just a matter of plugging in now. So we could, this is h prime of x. So we take g of x, x squared plus 1, times f prime of x, which is 1/3 x to the minus 2/3 power, minus f of x, which is x to the 1/3 power, times g prime of x, which is 2x, all divided by g of x, which is x squared plus 1, quantity squared. Now you could actually make this a little bit simpler in the numerator. So you could factor out a x to the, let's see, what do we want to do? We could do x to the 1/3. Let's do that first. So you factored out x to the 1/3. You'd decrease this by 1/3. So that would become x to the -1 power. And if you factor out 1/3 there, you'll get just what's left over, 2x. All divided by x squared plus 1 squared. Now, what I'm going to do is I'm going to take, I'm going to factor out another x to the, what am I going to do? What I want to do is eliminate this and just increase this by a power. So what I could do is if I multiply by x and divide by x, so I'm going to take this x and multiply everything in there, and this will be x to the -2/3 power, because I've got x to the 1/3 minus x to the first power. This gives you that, and so what I'm left with is 1/3 times x plus 1, and so x to the -1 times x is 1, and 2x times x is 2x squared. And then I could, I guess I could have, if I take 1/3 out of here, so it's going to be, I'm going to put the 3 in the denominator. I'm going to move this to the denominator, so what you'll get is x plus 1 minus 6x squared, all divided by, put the 3 from there to the denominator. This could be x to the 2/3 power, x squared plus 1 squared. So, you know, that's looks a little better than the original one, but I would just expect you to put this in here, and that'd be good for right now. The rest of this is just algebra, and I'm just thinking if I think that's right. Hopefully it is. I'll trust myself, which is probably not a good thing. Okay, the next one is find the equation for the tangent line at the given value of x. So you're given f of x equals -1/2 plus 7/5 x cubed at x equals 0. So you can see at x equals 0, y is, or f of x, which is y, is equal to -1/2. Because if I put 0 in here, this term disappears. I get -1/2. So that's my point. 0, -1/2 point. What I need now is the slope of the tangent line. So I take the derivative of f. There's f prime of x. So that goes to 0. 3 times 7 is 21. So I get 21/5 x squared. And this one's too easy, but just stick 0 in there. You'll get a slope of 0. Okay. Let's do it at, I was going to say let's do it at x equals 1 instead. Give us something a little more exciting. So we're going to do x equals 1. So plug 1 in here, you'll get 1 cubed. So we get -1/2 plus 7/5, and so that's get a common denominator of 10. So that's going to be 5/10 plus 14/10. So I multiply the numerator and the denominator by 5 and by 2. So you get 9. 14 minus 5 is 9/10. So that's going to be 9/10. So 1, 9/10. And if we plug 1 in here, we'll get 21/5. Okay, so now we use the point slope form of the linear equation to come up with the equation for the tangent line. So this is x1, y1. So we get y minus y1 is equal to m, which is 21/5, times x minus x1, which is 1. So let's go ahead and multiply this thing out. So you get 21/5 x minus 21/5. If we add 9 to both sides, or if you move this to the other side, what you'll get is 21/5 x minus 21/5 plus 9/10. Because when you take this negative term, move it to the side, it becomes positive. Okay, let's find a common denominator. So that's going to be 10. So we're going to multiply that by 2. So you get 42/5 plus 9, pardon me, 42/10 plus 9/10. So the final answer, equation of tangent line, is 21/5 minus 33/10. Okay, so let's plot this thing. So the original function is right there. So we'll plot that. -1/2 plus 7/5 times x cubed. Let's see what it looks like. And we're evaluating it at 1, so that looks good. We should be able to draw a line. Should have a positive slope. So let's go. Hopefully that's true. Yep. And it looks like it's going to end up being a negative y-intercept, which is true. So that looks good also. And then we put the line in, 21/5 times x minus 33/10. And we graph it. And lo and behold, you can see that x equals 1, that the blue line, which is the equation for the tangent line, is tangent to the red curve. So we did it correctly, which is great. Okay. And we got 2 more problems. Another quotient rule problem. So this is pretty straightforward. So we're going to take h of x equal to x minus 4 over x squared minus 7. So we'll let the numerator be called f of x. We'll let the denominator be called g of x. Pretty simple derivatives here. 1 and 2x. So the derivative of x is 1. Derivative of -4 is 0. Derivative of x squared is 2x. Derivative of -7 is 0. Okay, so now we use the quotient rule. H prime of x. I've already forgotten what it is. Let's go back here. G of x. Okay, so we'll start off with g of x. So we got this one. So you can have x squared minus 7 times 1 minus x minus 4 times 2x, all divided by g of x squared. And we can simplify the numerator here because it's just all polynomials, so it should be no big deal. So x squared minus 7 times 1 is x squared minus 7. Then we'll get negative x times 2x, so that's negative 2x squared. Negative times negative is positive. So we get plus 8x divided by x squared minus 7 squared. And then we'll just combine the two x squared terms. And that is what I get. So let's double check, make sure I didn't do anything wrong. looks good to me. Okay. And the last one is a little more complicated expression. We're going to use the product rule to figure out what the derivative is and then find the equation for the tangent line. So we have the function is this x squared plus 2x minus 2 times the sine of x. And x, this one I know is okay, so we're going to use x at 0.6. So let's first find the value of the function at 0.6. So we're going to have 0.6 squared plus 2 times 0.6 minus 2, put a parenthesis around the whole thing, times the sine of 0.6, which is, we're going to use radians. So when you open your calculator, make sure that your mode is in radians, which mine is not. So fix that. So we'll have 0.6 squared plus 2 times 0.6 minus 2, which is negative 0.44, times the sine of 0.6. And I get negative 0.248. We'll carry 3 numbers, significant figures. So that's the value of the function. So what we have is our point. Now we need the slope, so we'll take the derivative. And the product rule says, so we're gonna do it without writing it down. So what you do is you take the derivative of the first term times the second term, unadulterated. Then you take the first term, multiply by the derivative of the second term, which is the cosine of x. Now, I'm not going to simplify it because it's just as easy to evaluate here. There's really no way we can simplify it anyway, so let's see what we get. So we're going to have 2 times 0.6 plus 2, put that inside a parenthesis, times the sine of 0.6 plus 0.6 squared plus 2 times 0.6 minus 2 times the cosine of 0.6. So you can stick that in your calculator. 2 times 0.6 plus 2, the whole thing, times the sine of 0.6. And then we get the second term, which is 0.6 squared plus 2 times 0.6 minus 2. The whole thing times cosine of 0.6. And I get a slope of 1.444. I'm just going to take extra decimal there. So now we can just do the same thing. Point slope form of the linear equation. So you get y minus y1, which is negative 0.248. Slope is 1.444. X minus x1, which is 0.6. So you get y plus 0.248 is equal to 1.444x. And 1.44 times 0.6 is 0.866. And if we subtract 0.248 from both sides, we get minus 1.114. Okay, so we get our graphing program here again. We're going to go back to our normal stuff, and the equation is x squared plus 2x minus 2 times the sine of x, and it assumes your radians for this program. Okay, so that's the original equation, and let's just plot it and see what happens. So it looks something like that. and we're doing it at x.6, so it should have a positive slope, which it does. And so let's plot the line 1.444x minus 1.114, and that looks pretty good. So you can see right here my cursor is about 0.6. So yeah, it looks pretty good, doesn't it? So if you go to here to 0.6, you can see that well, actually it's slightly off, isn't it? Maybe it's just because of the rounding of something somewhere. So what I'm going to do is I'm just going to double check to make sure it didn't make any errors. If it's a rounding error or some other error, then I will let you know. If not, then I'm going to stop this recording.